in research is revolving around understanding the urbanization processes in developing cities, also building tools for simulating and predicting social spatial patterns of urban growth, and at the same time, developing and applying advanced machine learning models for generating socioeconomic data and predicting urban living conditions. Currently, he's leading the ESRC-funded project that seeks to model and predict urban expansion in Africa. He has published academic peer-reviewed papers in high-ranking journals, including Urban Studies, Environmental Planning, Urban Analytics and City Science, Applied Geography, Cities, Habitats International, etc. Dr. Agyemang has also provided urban planning expertise towards the development of plans and frameworks in developing contexts. Examples of such plans include the structure plan for the Greater Accra metropolitan area, and the Spatial Development Framework for Ghana, the Ashanti region, and the Northern Savannah Ecological Zone. Dr. Agyemang is committed to using his research and expertise to help shape policies that will improve urban living conditions in developing countries. Ladies and gentlemen, I introduce you to Dr. Felix S.K. Agyemang.
Thank you very much. Is this Francis?
Yes, this is Francis.
Okay, Francis, thank you very much. Let me share my screen with you. Please give me a second. I'm sharing my screen with you. Let me know when you can see my screen.
Yes, we can see now.
Okay. Sounds good. So let's look at some fun facts about data science in general. And I picked this from the University of Texas website. So to download information from the internet today, it would take about 180 million years, okay? 180 million years to download the quantity of information we have on the internet today. And that is if you have, a fairly fast downloading speed. Now, the UK's National Health Service has stated that by 2040, 90% of the data staff will be data literate. I picked these facts randomly. And there are nearly as many pieces of digital information as there are stars in the universe, right? So we know there are billions of stars really in the universe. Our solar system alone has millions of them. And there are many basically galaxies out there where there are stars, and there are billions of them, okay? There are nearly as many pieces of digital information today as the number of stars in the universe. Just think about that. I am Felix Agyemang, a lecturer at the University of Manchester, specifically lecturer in spatial data science. And today I'll be taking you through spatial data science, emerging innovations and future prospects. As an overview, I'll first talk a bit about data science and then move into spatial data science. Then we'll look at the emerging technologies in spatial data science. Job prospects, specifically, we'll be talking about the sectors that are ripe with job opportunities in spatial data science, and also some opportunities out there if you want to pursue further studies in
I can want them say a few weeks ago.
I think someone. Okay, that's good. Okay, so now let's start with data science. it's a fast-growing sector. I think you don't need to be told this. We hear data science a lot today than we did, say, even 5 years back or even decades back, because it is an emerging and it is fast-growing employment sector. The data we generate today is growing. We generate loads of data today. We're generating more data than we've ever generated before as human species. Not just the quantity of data that we generate, but the complexity of the data, okay? It's also increasing day by day. And what specifically is data science? So think of data science as a combination of maths, statistics, and computer science within a specific subject matter, or sorry, within a specific subject area, or with specific subject expertise, right? So you combine math, science in a specific domain. The domain could be planning, as in urban planning, could be environmental planning, or any other domain, right? So we combine these three, mathematics, stats, and computer science, within a particular domain to solve, problem, right? Use data to solve problem. So that generically is a very broad definition of data science, okay? Once again, combination of maths, stats, computer science to solve problems, or using data to solve problems. Now, how about spatial data science? So let's look at spatial data science more closely. And so it can be considered as a sub-discipline of data science in general. And spatial data science is a niche area. Actually, can I minimize my icons? I think so. Yep, I've done it. Spatial data science is a niche area, and it is an emerging field. It is quite nascent, so quite a recent field that is emerging as part of the data science bigger discipline or bigger field. And spatial data science is specifically focused on methods to process, manage, analyze, and visualize spatial data, okay? So you put spatial in the data science and you have spatial data science. So things we do or we perform on geographic data or spatial data, and that includes processing, analyzing, visualizing, managing the data in the real world to solve problems, right? To solve problems in the real world. That generically is the definition of spatial data science, or what spatial data science really is about. I will talk a bit more about the features of spatial data science. And I'll be in the slide. So we also have spatial data, right? And there are different sources of spatial data. Today, spatial data sources include the internet, which I would say is the number one source of spatial data at the moment. Mobile networks, GPS tracking, then we have satellite as we speak that is orbiting around the Earth and picking data from the Earth and also sharing the data with various data centers. I'm sure we've all come across, or most of us have come across satellite data before. Yeah, so these are the popular sources of spatial data that, we as spatial scientists, we process, work with, and all that, processing the spatial data, analyzing the spatial data, visualizing the spatial data, managing the spatial data, constitute spatial data science. Okay, so let's look at spatial data science a little bit more closely. Its features, right? So when you're talking about spatial data science, we also talking about spatial analysis. Right? I'm sure all of us have a guess of what spatial analysis is about. It's also about big data analysis, having data that is big in volume, in velocity, in variety as well. That is what essentially the definition of big data is. And analyzing big data is a key feature, a key component of spatial data science. And then spatial modeling and scripting or coding, you could say, it's also very cool or integral part, a core feature of spatial data science and data engineering. So data engineering, think of it as data manipulation, right? So you have your data, you manipulate the data, you query the data, you can also see that as some form of data engineering. You have one type of data, you process it into another type, you merge it with other data sets, you do some form of engineering there, or you manipulate the data, and some also refer to that as data engineering. Now, artificial intelligence and machine learning are also critical components or important components of spatial data science. And I would say most of the emerging technologies that we'll be looking at are actually coming from this stream of spatial data science, which is artificial intelligence and machine learning. I'm sure you've all heard a lot about AI these days because it's becoming an integral part of our daily lives, our routine activities, really. And also visualizing spatial data is an integral part of spatial data science. So initially, I said data science is growing, and spatial data science is also a rapidly growing field. And why is spatial data science growing? Francis, is it possible to pick up contributions? I think they can contribute, can they? They can talk, because I would want it to be interactive. So I'm not, just to make this clear, I am not Mr. All-knowing or Mr. Know Everything or know all. No. I've just done a research on this. It's an area that I work in, so I have some experience. But I would want it to be more interactive. Okay, so you talk, I talk. So if you don't mind, can I get some contributions here? Why do you think spatial data science is rapidly growing? Can I get some contributions? Francis, is it possible for members to contribute?
Yeah, yes. I think if he activates the chart system, of course, we can add some points there.
Mm-hmm. I think that some people might not have the right to turn on their microphone, but I think that would
be about the chat system.
Are they able to raise their hand for you to turn on their microphone?
Or if you can activate the chat system.
Yes, that they can raise their hands and then you activate the microphone.
Yeah. So let's explore that option, right? So I could hear voices, really. So please, you raise your hand and Francis will turn on your microphone and you can contribute. So why do you think spatial data science is growing or rapidly growing, to be more specific? Can see Kwabena Boafu wants to contribute.
Thank you very much for giving me the opportunity. For me, I think that data science is rapidly growing because of the involvement of the people who actually understand the use of the data and then the creation of the data. Now there's something we know as cloud sourcing, where other people are also contributing to the database. So the knowledge bank continue to increase because of the involvement of the outsiders who understand the use of spatial data. Hence, the rapid growth.
That sounds very, very interesting, Kwabena. So we have crowdsourcing or volunteered geographic information data, not just geographic information data, but just volunteer data. For instance, OpenStreetMap and other important platforms that are increasingly being used to solve real-world problems. They are available, right? So users of the data are able to contribute to the creation of the data or basically provide the data. And because they are end users themselves, they are able to provide relevant data and data, being used. That's interesting. That contributes to the popularity of data science in general and spatial data science to be specific. And that is something that I agree with you, Kwabena Boafu. Yeah, so that's an interesting point. Thanks, Kwabena. Any more contributions? Yeah, Jonas, go for it.
Thank you. I think the reason spatial data science is also rapidly growing is because we have a huge chunk of spatial data that is being generated day in, day out. I read somewhere that 80 to 90% of the world's data currently was generated within the last 2 to 3 years. And
Yeah.
spatial data is also an aspect of that data also contributes to that pure volume of data that's being generated. And
Yeah.
as spatial data continues to increase, there is the need for people who have spatial data science background or expertise to be able to derive meaningful insights from these data. And I think that's the other reason why that field is also growing.
That's fantastic, Jonas. I couldn't agree with you more. We as human species are generating more data than we have ever done. And that means there is something to process, something to derive insights from, and also opportunities to solve societal problems, opportunities to create jobs, opportunities to grow, to expand in many industries or sectors. And that means growth in data science, isn't it? You create jobs because you have more data, you solve problems because you have more data, and that expands the field. Can I take one more contribution, then we'll continue?
I think there's one in the chat.
Okay. Yeah, I mean, the things we do, local governments and central government do, are related to space, and spatial data is important. Yes, I agree with you, Peter, that contribution is also important. That most of the task of central and local government involve some form of data, and that means using more data, solving problems, and data science also becoming more attractive or gaining visibility and growing as a result. If it's being used by policymakers, then of course it's going to grow, right? Not just private sector or industry, but also policymakers or central government, local governments using data, spatial data to solve problems means spatial data science as a field is going to gain popularity and grow as a result. Let's see the point that I also captured here. Technological advancement, right? So we are in the era of technological evolution. We have, like I said, satellites orbiting the Earth at the moment as we speak, and capturing lots of data and making that data available to us, right? So now we can, now we have more data available to us, and also we have more techniques, right? More analytical, artificial intelligence techniques, machine learning techniques to process this data, right? And that is quite important, and that is contributing to the rapid growth of data science. Day in, day out, we are generating data and consuming lots of data, and that also comes with increased requirements for the type of data that we consume, and that also grows the sector. Look, industries are changing their processes, adopting more efficient data processing techniques, looking for optimized or optimum ways of processing data, storing data, or using data to solve problems, using data to create jobs, to grow. So there is that industrial demand or industrial change also taking place at the moment, and that is contributing to the expansion or the rapid growth of spatial data science. And yes, we have new data sources. Imagine the quantity of data being generated with our phones today. Think of a decade ago, or say a decade and a half ago. Let's go to 2000. So say 2 decades ago. where mobile phone wasn't as prevalent as we have today. But now look at the data that we generate just by using our phones today, right? And also there are new analytical methods that are available to process the high quantity of data being generated today. Okay, so all of these put together means we are in a data-driven world. Okay, so data is the new gold, is the new timber, is the new salt, I would say. Industries that are able to compete favorably in the data world would have the upper hand, are likely to grow faster and win the competition, really, or stay on top of the competition. There are some emerging innovations in spatial data science, and they are a lot. We cannot capture all of them, but we're just going to highlight some of the key innovations, right? I don't know whether you've heard the term Geo AI, which is Geospatial AI. That is increasingly becoming popular, especially over the past couple of years or so. So it's basically the application of artificial intelligence fused with geospatial data, science, and technology to solve real world problems, right? So we know what artificial intelligence techniques are, but here we're talking about specifically geospatial artificial intelligence techniques, right? And there are lots of them out there. I might actually along the way mention some of those techniques, right? We also have machine learning. So you can think of machine learning as a subset of AI that focuses on computers acquiring knowledge to iteratively extract information and learn from patterns in raw data. And there are lots of machine learning techniques out there. Nowadays, everything quantitative is being packaged as machine learning. People do and basically neural regressions, and they're still called. Of course, technically they are. Technically, it is machine learning, but there are more sophisticated machine learning algorithms out there that are quite interesting. Random forest and k-nearest neighbor. There are lots of machine learning algorithms out there that are increasingly being used in spatial data science. So still talking about the emerging innovations, one is deep learning. How many of you have heard of deep learning? Has anybody heard of deep learning? A quick raise of hand, and maybe get someone to talk. Has anybody heard of deep learning? Anybody? Okay, so deep learning as a form of machine learning. Okay, and I would say that is the high end of machine learning, the very advanced end of machine learning. That is increasingly becoming popular today. Or you can say the cutting edge type of machine learning. It draws inspirations, or it tries to mimic the human brain. So all of us, right, what makes us humans, or what makes we humans more intelligent than any other species, right, is the fact that we've got billions of neurons. Okay, so if you compare the number of neurons we have as humans in our brain, they are exponentially more than what animals have, right? We have billions of neurons in our brain. As I'm talking right now, some of my neurons are firing. Of course, we don't tend to really optimize or use them in full capacity. But the point here is that the brain is composed of neurons, lots of neurons, and these neurons are interconnected, right, in a way that makes us function as intelligent species the way we function. So what deep learning does is it tries to mimic how the brain functions. Okay, so if you've heard of artificial neural networks or neural networks, most neural networks are actually deep learning techniques, right? So you would have neurons in the networks. They're actually mathematical nodes, but then we call them neurons, and these neurons are interconnected in layers, and each connection has a weight, and the neurons are set up basically to mimic how the human brain functions, right? And this technique is so powerful that it enables computers to learn. Okay, so if you've heard of self-learning, it enables computers to learn by feeding it with data, and then it's able to basically replicate that data, or it's able to use the patterns that it learns from the data to predict for you. Okay, so you train a deep learning model or a computer with the training data you have. You withhold some of the data from the computer, you show it to it after it has finished learning, basically testing the computer whether it learned well, that what is this, what is that, and the computer will be able to tell you what it is, really with high level of accuracy. Now the accuracies are getting stunning or crazy, just increasing day in, day out. Most natural language processing techniques are based on, or models are based on deep learning. So when you interacted with ChatGPT, at the very base of ChatGPT somewhere, it's a deep learning technique, right? So that is also a powerful emerging innovation in data science or in spatial data science. So there is also spatial data science deep learning models. Personally, I have built a deep learning model that looks at satellite imagery to predict poverty in rural areas. And this model was applied in Pakistan, and it's able to do so with 70% accuracy, right? So it picks, so if you take a big area, you standardize the area into 1 square kilometer grid cells, as in satellite imagery or tiles that measure 1 square kilometers, and then you feed that into the model. The model will predict whether an area is poor or not poor, and in about 70% of the times, the model will be getting that right. And we even trained the model with noisy data set. It was difficult to get poverty scorecard data in Pakistan. So we trained it with data that we had, which wasn't really great, was noisy. And even with a noisy data set, the model was able to perform basically 70% correctly most of the classification problems that we threw at it. So this is also a powerful emerging technique. If you've not heard of deep learning, please today take it and look into it a bit more. I'm sure you know LiDAR. Most of you do. So LiDAR really, it's used to collect 3D data, 3D geospatial and environment data. So most of the building height data we have today comes from LiDAR. That's also a powerful technology that is increasingly being used in spatial data science. And last time I was in Ghana, which was last year around July, August, about, I laid my hands to some data that had been, that had been freshly generated with LiDAR, which is basically building footprint for some sections of building height for some sections of Accra. That is increasingly becoming popular, the usage of LiDAR in GIS work, in spatial analytical work. It's increasingly popular, and also in hydrology, those that are into flood modeling, generating more accurate 3D models or 3D data to necessitate or to support flood modeling. Actually, LiDAR is increasingly being used. And so LiDAR is light detection and ranging. Sorry, if you I didn't mention that, just to say that. And then there is also augmented reality. I'm sure most of us know augmented reality. And now there is increasingly geospatial augmented reality, right? So it's not just you go somewhere and then you wear and you see things that are not real, but then you feel like you are in it. Now you can use it to visualize 3D. You can use augmented reality to visualize 3D geospatial data, right? And then be able to then analyze those 3D 3D data sets, geospatial data that you're seeing, if you have expertise in that. Okay, so now we're able to solve geospatial problems using geospatial augmented reality. So that look out for it is also going to be something that is quite popular in the coming years. Already is gaining some popularity as we speak. There are also computer vision. Computer vision is basically similar to deep learning technique that we talk about. But so deep learning is more specific. It's one of the methods or one of the techniques that computer visualizes, or that computer is able to detect. It's able to see. Let me put it, bluntly, in a very basic way of expressing that. So AI that enables machines to interpret and understand visual data. So you feed the computer with an image, okay, and then it tells you what the image is, right? I'm sure you've seen the Microsoft challenge of classifying things. Almost every year, Microsoft issues this challenge where developers and data science gurus basically compete, trying to develop a model that performs best at classification or regression problems. So yeah, computer vision is also increasingly becoming popular, developing an AI model that visualizes, or that is able to detect or at times segment data imagery, basically using some techniques behind it or in the background. And one of those techniques is deep learning or artificial neural networks, which is also quite popular. But yeah, computer vision is basically computer detecting what images are. It's also quite popular or emerging innovation in spatial data science. So edge, I'm sure almost all of you have heard of cloud computing. How about edge computing? Anybody with knowledge of edge computing, or who has heard of edge computing? Anybody? So when you think of edge computing, right, or when you hear of edge computing, just to put it in the most basic terms, or express it in the most basic way, as processing data, okay, in a way that the data is closer to where it's being generated, right? So think of networks or architecture or computing paradigm where the processing of the data takes place to where the data is being generated and used. Okay, so when that happens, it increases the speed at which the data is being processed. Okay, the data processing is not taking place at one physical location that could be quite distant from where the usage is occurring, for which reason, because of that distance, that slows the processing speed. Now, this is a more flexible architecture or paradigm, computing paradigm, where the processing is taking place closer to where the data is being used. Okay, so in that case, it reduces that distance, and then the distance between where the data is being used and where the processing is occurring, and that increases the speed of the processing. Okay, and that can be used to process geospatial data in real time. Okay, so if you have good you have good computing power, then with edge computing, you'll be approximating real-time processing of data. Okay, so if you haven't heard of that, please also look forward to that. That's going to be quite interesting to know more about in the coming years. Right. So, these are some of the technologies, the emerging innovations. And let me talk about these two, then we'll talk about some job prospects. Blockchain, I'm sure you've heard of Bitcoin, right? That uses blockchain or distributed ledger, really, and it's just for security. And that can also be used to decentralize, to create or to develop a decentralized system for managing spatial data. Okay, so if you have a central government that is very concerned about security of how data is managed, stored, you can use blockchain to actually create a decentralized system where district assemblies or local authorities can use that geospatial data without compromising security, right? So blockchain is also increasingly now becoming popular in spatial data science discipline or field. Graph analytics, okay? So the data we generate, data at one place, it moves to another place. So when data is generated at one place, then it moves to another place, or it's being accessed at a different place, it means there is a node, which the node could be where the data is generated or where the data is being used, and in between is an edge or a connection, right? So then you have something we call graph. So we have graph, and graph analytics is becoming popular, right? And that can be used to explore or analyze spatial networks, spatial relationships, spatial flows, movement from one place to another, right? And that is quite important for spatial or geographic analysis. So graph networks or graph analytics is also becoming very popular, just like deep learning. It's actually a form of deep learning, really, technique. So we have convolutional neural networks that are increasingly being used for raster analysis or for image analysis. But when you have vector data, right, so we have lines, graph analytics, and then you want to explore flows, try and identify discernible patterns in flows, in networks, in relationships, then graph analytics. And one popular technique in graph analytics is graph neural networks, as becoming quite popular. So if you haven't heard of graph analytics, please look into it. It's a powerful subfield in spatial data science that can be used to explore powerful spatial networks, relationships, and flows. So you also want to have a look at that. Okay, so there are a lot of sectors with job prospects at this point. Yeah, almost every sector has a job opportunity for spatial scientists or spatial data scientists or data scientists, however you want to classify it. And gone are the days that you would think of the only way of being recruited or putting your skills to use is working for, say, a planning institution or a spatial oriented institution. No, the skills you have as a spatial data scientist is relevant in many disciplines, in many sectors, okay? And one of such sectors is technology. So technological companies are increasingly becoming popular, and there are new startups almost everywhere. And yeah, it's an industry that recruits quite a lot of data scientists and spatial data scientists, consulting and research firms. I don't think that needs any explanation. Manufacturing and retail as well. Also quite popular. Professional services, popular healthcare. Yes, healthcare. Spatial scientists are being recruited in healthcare fields. And continuation of the sector, so a lot of opportunities. You can also work for not for profit sector. finance and insurance. Despite the economic woes of Ghana recently, where most sectors shrank, the fintech, the ICT industry grew, right? I've forgotten what the figures are, but yeah, billions of Ghana cedis is what is quantified to be the size of the fintech as the financial technology sector in Ghana, and it keeps growing. Right now, you hear a lot of digital stuff in Ghana, digital businesses, digital spaces, and even now the politicians are beginning to fight over who introduced digitalization and who started it and who did not start. That should tell you that now it's becoming mainstream, right? Who would have thought that some time ago, maybe 2 decades ago, digitalization would become a key component, in our political discourse in Ghana. But now it is. That should tell you how fast data science, visual data science, is growing. So yeah, finance and insurance is also a field that has a lot of job opportunities for you as a data scientist or visual data scientist. A lot of science organizations as well, startup businesses, across board, in Ghana, outside Ghana. Yeah, there are lots of startup businesses that require data scientists, visual data scientists. So yeah, you want to take note of that. And then government agencies. Yeah, I put that as the last one because traditionally, if you're doing, if you're a member of Geospatial Science Society, most likely you're doing something to do with GIS, spatial analysis, and you might think, you know what, why not work for the district assembly or local authority? There is nothing wrong with that, okay? That is fine. But that is not the only avenue for you in terms of job prospects or where you could put your skills to use. That is quite obvious. I put it at the last, but there are lots of other sectors that you could explore, you could look at. So if you're interested in pursuing further studies in spatial data science, I have this is basically UK-based institutions, and this list is by no means exhaustive. There's just a sample, really selected few of key universities here in the UK. I started with the University of Manchester because I'm biased. That is why I lecture. And yeah, it is a Russell Group University, quite good. We have a course in MSc in data science. We have several pathways, and one of the pathways on that program is urban analytics pathway. So if you're interested in wanting to pursue further studies in data science, we have MSc in data science, urban analytics pathway. The other pathways, okay, so if you're into environment, we also have environmental pathways, environmental science pathways. We have business management pathways. We have pathway. We have social statistics pathway, all under the MS data science umbrella. Okay, so if you pursue the urban analytics pathway, what you get is MSc urban analytics data science. Right, so that is what you get. University of Bristol, which was where I was before joining the University of Manchester, is also popular when it comes to spatial analytical courses. You also have a program, MSc Geographic Data Science and Spatial Analytics. That is quite popular. So our University of Bristol is also one of the top universities in UK. University of Liverpool, just about 40 or 50 minutes drive from Manchester. It's also quite popular. MSc Geographic Data Science program is quite popular in the country. UCL is very strong when it comes to spatial analytics. So I'm not surprised that they also have a program in MSc Spatial Data Science and Visualization. It's quite a popular one as well. Like I said, this is by no means an exhaustive list of MSc or Masters data science programs in the UK. There are a lot more out there, but these were the select few that I decided to present. And of course, not just UK, there are lots of opportunities outside UK, opportunities in the US, in Africa, even in Ghana. Actually, Ghana, I'm not too sure. I'm not too sure of Ghana at this point in time. I need to do my research and stay updated on that. But certainly different countries in Africa, especially South Africa, Kenya, and then outside Africa, US is also quite popular when it comes to data science programs. All right, so we've got 3 minutes to go anyway. So that's all, by the way, what I put together to share with you this evening. Thank you very much. And if you have any questions, please throw them.
Thank you very much, Dr. Juman. I think you found the right audience, and I'm sure many people would be interested in some of the lightnings you've put across, and also the prospects that people could explore if they are already into this field, or if they want to go into this field. I think these are some of the things that many people here are interested. If someone has a specific question for any of the slide that you want to talk about, or probably you want an inquiry about something that has already been said, we have very few minutes to go.
And I think we can use the same format, isn't it? You raise your hand and Francis will unmute you and you can shoot your question. I think Bright's hand is up.
Yeah.
Okay. Hello.
All right, you can go ahead.
Thank you, Mr. Felix, for a wonderful presentation. I just want to ask, with regards to pursuing masters in data science, what is the minimum requirement? Is it just BSc, or there's any other thing that you need to add? Thank you.
Thank you very much. For our department, if you have a BSc, that alone is sufficient. You have a BSc, and of course, if for admission, a BSc with second class upper minimum, second class upper is good, really. Even second class lower. So second class lower will be the equivalent of 2.2 here. So we have one is first class. We have 2.1 will be second class upper. 2.2 will be second class lower. However, if you want scholarship, then that is different thing altogether. So scholarship comes with competition. Then it also depends on the scholarship source. If you want to compete for the few scholarship source here in Manchester, then that requires that you really can compete with others. And normally first class is a strong advantage, or a very strong second class upper. If you're not worried about scholarship and it's about admission because you have other sources of funding your studies, then generally second class is fine. Second class BSc is fine. Of course, you're going to write a personal statement, and that is where you'll be able to also bring on board other experiences that you've acquired. But yeah, BSc is sufficient as a short answer to your question. I think Osman's hand is up.
Yes, we've asked him to lower. I've asked him to unmute himself.
Hello.
Okay.
Hello, Doc. Good evening, and thank you for the presentation. Yeah, please, I want a bit of clarification. Is there a difference between geospatial science and geospatial data science? I am currently pursuing an MPhil in geospatial science, but I just want a bit of clarification. Thank you.
Thank you very much, Osman. I would say it's really semantics in terms of content. Mostly they're going to be identical. if not highly, I mean, they're going to be highly similar, if not identical. So I wouldn't worry about, okay, geospatial science, geospatial data science. Really, you're talking about in terms of methods, in terms of techniques, right? So I would say it's more about the content, the knowledge you learn, and what you're taking away, what techniques are being taught. It's not so much about the nomenclature or the broad definition of what the names mean. Really, no, it's not about that, because the names can be used, loosely depending on the context, right? So, like, for instance, if you see the programs that I showed you, the further studies that you can pursue here in UK, some call it geographic data science. For instance, Bristol, that is how they call it. Here in Manchester, we call it urban analytics, data science. We have spatial data science, UCL, Liverpool calls it geographic data science. So yeah, there are different variants in terms of the name. They try to, of course, make the name more attractive, more catchy, depending on what they mean or how they define attraction and being catchy. But I think what's important is the content, right? Spatial science and spatial data science content are most likely going to be, similar, if not the same, really. So I would say don't worry so much about the names, because they are highly similar. Don't have a hardcore science distinction between the two.
Okay, I think we will take the last question, which is in the chat. Jimmy is asking, in terms of data ethics and privacy concern, how do you suggest balancing the utilization of spatial data for innovation while ensuring the protection of individuals' privacy as well?
Yeah, ethics, that's an interesting one. Ethics is quite important. You don't want to jeopardize people's privacy. That's a no-no. So blockchain, for instance, is a way to increase security. So if you thinking of increase security in how you store your data, you manage your data, then you could create, like I suggested, a blockchain to do that. Yeah, so that is one way, but I'm sure there are other different ways of basically increasing the security protections of data storage systems and management systems, and that is quite important, really.
Okay, thank you very much, Dr. Juman. Right, unfortunately, we are 5 minutes past our time, and we wouldn't want to take too much of the time of Dr. Juman.
I don't mind. Really, Bright, if you can make it snappy, why not? Go for it.
Okay, that's fine.
Okay, Doc, thank you very much. Just a follow-up question to what I just asked earlier. So do one need to have a strong background in programming before one will be able to pursue a data science course?
No.
Thank you.
No. The answer is categorically no. So programming is just one of the fields that data science emerged from. There is statistics, which is even very broad. There is math, which is very broad. And you don't have to pursue degrees directly in this. You could have pursued, or you may have pursued, a degree that uses these. Okay, so your degree, you may have done research methods that included some bits of statistics. You may have done a course that included maths, right? And that's fine. Here, especially in Manchester Urban Analytics, you don't need to have prior knowledge of programming, not at all. I teach. I have a new module that is going to come on stream as a new unit, and that is AI and spatial analytics with Python. that starts from scratch. It assumes that participants have no prior knowledge of programming at all. So they will be introduced to the basics of programming. You start from the very scratch. So yeah, the simple answer to your question is that no, you don't have to have prior knowledge of programming. When it comes to that of Manchester, and I suspect would apply to most universities as well.
Yes, Doc, this is Michael. So I have a little question though. So I've been looking at data science on its own, looking at just the data and doing predictions on it, and then doing predictions on the geospatial data. In which way are the two different from each other? And how would the two complement each other?
Sorry, I didn't quite. Sorry, I didn't quite catch your question or understood it.
Okay.
Yeah.
So I am looking at data science standing on its own.
Okay.
And then someone mixing data science on geospatial data. For example, if I want to predict dam spillage, I may call it just the prediction of the dam spillage, not necessarily geospatial science. Another person may then want to do that in the context of the geospatial data science. How do we mix these two and get the advantage out of the two fields?
I mean, I wish I really understood exactly what you mean by mixing the two, because either of them, it's not just about prediction. Either of them is more than prediction. So the scenario you created or you cited with predicting dam spillage, right, is just a minute component of what spatial data science entails, right? And spatial data science in itself is within data science, right? So there is some form of integration. It's not like spatial data science is sitting at one place and data science is sitting at the other, right? So spatial data science is a more specialized, field. It's a niche field under data science, right? So you could technically say that spatial data science is data science, depending on who your audience is. But then if you want to qualify it, okay, then you'd say spatial data science, right? Like say, okay, someone is a doctor, we have doctors that are specialized in specific parts of the body, right? But generically, you can say they're doctors. So think of it in that terms, that spatial data science, it's not isolated from data science. It's just a branch of data science. Does that help?
Yes. Thank you very much.
You're welcome. You're welcome.
All right, ladies and gentlemen, thank you very much for attending this session. We hope to bring you more of this and keep you updated in what's trending in the industry. And we also hope that you have received information that will guide your decisions and also help you to be able to pursue your career. Dr. Ajima, thank you very much for having us, and we are grateful for spending your time with us. And we hope to have more interaction with you, probably some other time where we could get to see spatial data science in action and be able to appreciate more of what it can do. But in the meantime, we're saying thank you very much, and we hope to get back to you again in the near future.
All right. Thank you very much, Francis, and thank you to all of you. It's been nice interacting with you, and good evening.
Good evening.